All right, welcome back. So in this particular video, what we're going to be doing is we're going to be getting acclimated with Cube IDE and go ahead and fire that up. And so hopefully you've installed it. This video series isn't really about how to install it. So hopefully you can just go to ST's website, download it. It's based on Eclipse. Basically it's Java. And so it should work on pretty much Windows, Linux, OS X. So hopefully you can get that installed on your own. So we can go ahead and focus on how to use it once you've got it. Okay, so you should look like, your system should look like this, where you're in here, it's basically a blank slate. And what you're going to do, and so this is really based on what's known as Eclipse CDT, which is a C version. Eclipse is originally created for doing Java. And so the Eclipse CDT was created to do C and C++ applications. It's been used as the platform for other systems like TI's Code Composer Studio, those sorts of tools. I mean, it's a really nice platform as a starting point, and it can be modified by, say, a vendor to tailor it so that it's an easier way to get started. To be honest with you, in this class, I have done command line things in the past so that it was easier to see what was going on under the hood. It's gotten to the point where I'm not sure that the value of that is commensurate with the effort that it takes to get started. And so, especially when it comes to getting debugging going. I've decided to use Eclipse. So I thought I'd make these videos for getting people going. So the way you start with Eclipse is you're going to create a new project here, a new STM32 project is the way we're going to do it. You of course could use CubeMX and bring in that .ioc file and start from that. But we're going to start fresh from a brand new STM32 project. And so let's go ahead and I'm going to click that here. All right, and bring up the pop-up because my video recording software here. Let me make sure I can get to it here. Okay. My window here that basically lets you select the particular device you're using. Of course, this is the whole product line, and you can get a really good idea of all that ST has to offer. And so, I've used lots of vendors, processors from NXP to TI to, in the old days, I used Motorola processors. And so, ST has a very fair lineup, and they're very cost effective. It's been my experience, and so at least in low volumes, they're cost effective. So I think that they've got a really nice solid lineup, and so staying in their tool systems has been effective for us here at IU. But if you're in high volume production, you may have a different opinion. Certainly, people have different opinions on those sorts of things. All right, so you can select the particular processor. So of course, these are all ARM cores. They're all Cortex-M series processors, I believe, all M's. Either M0s or M3s or M4s. The L432 that we're using is a Cortex M4. It's got a floating point unit. And so you can select it by the MCU, and so it helps you kind of, if you're in the embedded space, of course, we are always looking to optimize cost, right? I mean, and so you don't want any more memory than you have to. You don't want to pay for anything that you don't need as far as peripherals or memory. And so very judicious about how you select those. The packaging matters a lot. So processors come in many different packages, and that's why you'll see in this selector interface, it's pretty complicated in the sense that it's got lots of different options, which as you design more things is more important, right? Because you want to really optimize for your particular custom design, right? In the embedded world, that's what we're doing. We're designing custom electronics to solve some problem, right? So I'm going to go to the board selector here, And I'm going to this board, so these 3 tabs here, you can select, different ways of getting at the particular ST hardware you're trying to use. And I'm going to come up here and I'm going to put in L432, and it will bring up my board, the board that I'm using. And so I'm going to highlight it, and then I'm going to come down here and I'm going to say next. I'm going to select that as my device, and it gives me this little dialog here. So I'm going to give it a new project name. I'm going to call it L432 web example. And this is okay. I'm going to do C. I'm not going to do C++. This is, it's a small memory footprint machine, right? It's got 40K of memory. It's not that much. So C++ always makes you a little nervous when you start constructing things that start allocating memory. And so I tend to use C in these sorts of projects, but that's certainly up to you, your preference. But I would say C is a good solution here. And we're going to go ahead and finish this. And I'm going to say yes to initialize all peripherals as their default mode. And it is creating the project for me, and I'll switch back to my, it's taking a minute for some reason. Switch back to my interface here. So I'm back in the Cube IDE. And so here we are. It's got this, those of you who are familiar with the Cube tools, CubeMX, which is a standalone tool that'll generate the C code in the make files or whatever debugging system you use, if you're using the Kyle stuff or whatever. It'll generate the project files that you need for those. So what we're going to do here is let me open up the main file, and you kind of see there's main. And what I'll do is I'm going to end this video here. That kind of gets us, we've got a processor selected. We've selected the board. And, of course, this example is designed to know about things on that board, like the LED and how the debugger and the serial port are connected. So it knows about that, and it's embodied that in this template code that it's given us. So next time what we'll do is we will build this template code and drop it into our board and just prove to ourselves that, yes, indeed, this code will run on our target hardware, which of course is this little demo board here. All right, so all for now. We will come back in the next video, and we will go ahead and compile this code.